Hello out there. Welcome to a C programming video. Today we're going to talk about the game Snake and what it takes to make it in C and SDL. On the screen in front of you is Sammy, or Jake. I can't tell those two apart. While we're here, let's talk about the components of the game and how we're going to code them. We're going to have to monitor directional changes, food consumption and respawning, the length of our snake, the boundaries of the game, and our various body sections. First, we need to envision a place for our snake to live, an area for it to move around, the food to spawn. Looking at this grid, you may think we create a game board, but there is no game board. Instead, we're merely a bunch of points in an array constrained within the playing area dimensions. When trying to mimic the movement of snake, it's important to remember the game is old, and so if we use a low frame rate, it looks and acts much like it did decades ago. Here, we're going to be using 10 frames per second and playing on a 24 by 24 grid. Since our grid is so small, we'll also have to include a scale, otherwise we wouldn't be able to see the game. Next, we're going to need a way to track dimensional input. Here, we're going to enumerate a series of directions for tracking input numerically. You can use whatever method you like as long as each direction is separate and there is a non-directional state. Now, we're going to define our point structure. It's an easy way to track points as any point variable will have both an X and Y location. Onto the snake structure. It's going to track the points in an array the size of the game board, keep track of the length of the snake as well as the direction the snake is heading. We arrive at our first function. Is snake checks to make sure that the points we're checking aren't within the body of the snake. It's important to note that in our for loop, we start the count at 1. Otherwise, the head's coordinates would collide with itself, and the check performed would fail. Next, in the update snake function, we're going to temporarily store the head's coordinates before checking the direction. Next, we're going to pass the directional input and increment or decrement our temporary coordinates. Once we make sure we didn't hit our body or go out of bounds, either of which would end the program. If we didn't perform these checks, we end up with a very different game. Not very challenging. We then update the body array in a for loop, moving the data one spot over in the array as this very professional infographic depicts. Now we store the temporary X and Y into the head portion of the snake array. This brings us to our init function. We will assign our initial position to be half the vertical and horizontal maximum. We will also make sure our body starts off with an initial size of 1, and that our directional status is none. The doGame loop is where we have all the main logic and sequencing for the program. We have static variables such as the snake struct, a food point as well as a food consumption tracking variable, and a variable to track overall initialization. We will now check if we have initialized the game. If we have, we go to the next part, which is handling the controls for the snake, making sure to eliminate the ability to fold back upon ourselves. This is now the section that will consume a piece of food, increasing the length of the snake, in this case by 1, and sets the food variable to 0, indicating we need to spawn food. Checking to make sure we have a valid position, we move forward. Here we're doing a few things. We're generating a random position for the food and making sure it isn't the snake body or head. If it is, we continuously generate until it is not, then toggling the food variable. Using SDL, we will draw a border around the playfield to help distinguish the edges, draw the food at its location, and then draw the snake. If you notice, we're using the scaling to make 10 by 10 boxes, and in the case of drawing the snake, we're using a for loop to draw all the sections. In the main function, we're going to initialize our SDL window and renderer. Here, I also added another scale function as my screen recorder didn't like the 240 by 240 window, so I doubled it for the video. We then seed random with the address of our main function to eliminate seeding with the time call. In the event loop, this is how we capture the directional data for the doGame loop. In this section, we call the individual functions that make the game run. The link to the source code is in the comments section. I hope this video helps you understand the mechanics of Snake and how to bring it to life. Until next time, thanks for watching.